Rationalizing the denominator in rational expression. Our objective today is that you will study how to rationalize the denominator in rational expression using the rules of exponent. So here is the properties of exponents review. We say that when you multiply two equal bases, then we can add their exponent. And here's an example that looks like that. So if you have x to the second and x to the fourth, adding their exponents give me x to the sixth. If you have power of another power, a to the m to the nth, then we are multiplying. We're going to multiply those two powers. So a to the m to the n is a to the m times n. And then if you have product of a power, then we need to take each factor a and b and raise it to that power. Or even if you have a quotient of a power, you do the same thing. You take each factor and raise it to that power. Then when you want to divide two equal bases, we're going to subtract their exponent. Then we also look at if you raise any number other than 0 to a 0 power, then you get first. So we can raise 0 to a 0. That's undefined. But if you raise something a to a negative n, in that case, you don't want to have a negative exponent. So you got to rewrite it out of a is positive by writing a reciprocal of it. So if you have x to the negative 3, then to write it as a positive exponent, we're going to say that is 1 over x to the third. Once you write it as a reciprocal, the negatives goes away. And then the last thing that we look at is this, and this is what we're going to focus on today. Say if you have a to the 1/3, the 1 is your exponent, the 3 is your index. So you can rewrite this as the cube root of 8. And as you can see, yesterday we talked about, okay, what number, not yesterday, the last lesson, we talked about 2 times 2, what numbers when I multiply 3 times give me 8. That will be a 2, that's why my answer is 2. And yeah, as you can see, it's right here. Or if you have a to the 2/3. Okay, if I have a to the 2/3, again, my number on the top of my fractions is my exponents, and then the denominator is my index, so I can rewrite it is at the cube root of 8 squared. 8 squared give me 64, and then we kind of think, okay, what number when I multiply 3 times, because my index is 3, gives me 64, and that is a 4. And as you can see here, you can break it down as 4 times 4 times 4. There are 3 of my 4s under my radical, so I can take that out and my answer is 4. And as you can see over here, one more example, I have xy to the 3/4. We can do the same thing. We can rewrite it as the 4th root of xy to the 3rd. So let's look at one more rational exponents review from pretty much last lesson. So if I have the 4th root of 36a squared b squared, how do I simplify this? How do I simplify this? So to do this, we're going to say this is equal to, we're going to try to write it as exponents for this one first. So I can rewrite this as 36a squared b squared to the everything to the 1/4, because I have a 4th root of that. So then I'm going to, looks like I have power of another power. When I have that, we're going to multiply their exponents together. So this is going to give me 36 to the 1/4. A to the 2 times 1/4 give me 2/4. And then b to the 2 times 1/4 gives me 2/4. Then we have 36 to the 1/4. All right, can 36, can I say simplify them, or can I make that into a smaller number? And we know that 36 is a perfect square of 6, so I'm going to say this is the same as 6 to the square of 1/4, which is a to the 2/4 and b to the 2/4. Then we're going to simplify this a little bit more. All right, I have 6 to the 2/4. So 2 times 2, 1/4 is 2/4. Can I simplify 2/4 here? Yes, I can simplify this as 6 to the 1/2. And a to the 2/4 is also a to the 1/2, and then b to the 2/4 is also b to the 1/2. We can either write this answer as, put everything in parentheses, 6a and b, because they all have exponents of 1/2. So I'm going to write, put them in parentheses, and they say this is 6ab in parentheses to the 1/2. Or another way to rewrite is that you can rewrite this as a radical. Say this is a 2 root of 6ab. And as understood, we usually don't write the 2. So I'm going to go ahead and erase that 2. So square root of 6ab. You can write your answer in any form, which is the same thing. So you can either say parentheses 6ab to the 1/2 or a square root of 6ab. Alright, here is 2 practice problem for you to do real quick. I'm going to give you guys about 2 minutes and then we'll look at this together. I have number 1, I have 27 to the 1/3. So to simplify this, I can rewrite this as a radical form 3 cube root of my index number, which is 3 cube root of 27. Now we usually say, okay, when you have a cube root of 27, think of a number that you multiply 3 times, you get 27, and we know that that's 3. So I know that my answer is 3. But to see this, to visualize this, this is the same as a cube root of, we say if I multiply 3 times, I get 27, right? So 3 times 3 times 3 gives me 27. Therefore, my answer is 3. Or a lot of times you can say, because my index number is 3, and I have 3 3s in here, so I can take it out, and when I take it, I only get 1 3. So there are a few ways to see this or to think of that. Alright, number 2, I have the 6 root of 27, a to the 9th, b to the 6th, and c to the 3rd. So we can do this a few ways, but let's do it as, say, I'm going to rewrite everything in my exponents, put it in parentheses. I have 27, a to the 9, b to the 6th, c to the 3rd, all of everything's raised to the 6th power. Then we are going to say, okay, 27 raised to the 6th power is 27 to the 6th power, but can I is 27 is a perfect square root or perfect cube root of something? As we can see here, it's 3 to the 3rd power right here. So I'm going to rewrite this as 3 to the 3rd power raised to the 6th power. And then, yes, 3 to the 3rd power, I need to raise everything to the 6th power. Then we're going to say a to the 9th power, raise that to the 6th power. B to the 6th power, raise that to the 6th power. And then c to the 3rd power, raise that to the 6th power. Alright, then we can multiply our exponents together, and we can say this is the same as, wait, this is not 6, this is 1/6. Sorry guys, like this is 1/6, 1 over 6, 1 over 6, 1 over 6. Sorry, raise it to the 1/6 because this is the cube root of 1/6. Now we're gonna say, okay, 3 to the 3 times 1 over 6, so that gives me 3 to the 3 times 1/6 is 3/6, which is 1/2. And then a to the 9/6, so 9 divided by 6 gives me 3/2. So this is 3/2. B to the 6 over 6, that gives me 6 times 1/6, which is 6 over 6 is b. And then c to the 3 times 1 over 6 is 3/6, which is 1/2. Alright, and then we can come below here. Okay, I have a to 3 to the 1/2, a to the 3/2, b, c to the 1/2. Now when I look at my a to the 3/2, so because my 3 is greater than my 2 right here, I can rewrite this as 3 to the 1/2 times a square times a to the 1/2, because 2 plus 1/2 gives me 3/2. B and then c to the 1/2. Now that I have this, I'm going to rewrite my answer as, I have a, no, not a to the square, sorry, it's just a 2 to the 1/2, 2 plus 1/2 is not, it's 5/2, not 3/2. So it should be a times a to the 1/2, sorry. So that should be 1 plus 1/2 will give me 3/2, right? So I'm going to rewrite my a as this. Now as you can see here, I have my, oops, not that. I have my A and I have my A here and my B here are by itself. It's not raised to 1/2. But on the other hand, I have the 3 to the 1/2, A to the 1/2, C to the 1/2. So to rewrite this as my answer, I'm going to say I have an A and B that is by itself, and then I have 3 A and C that is raised to 1/2. So you can either leave your answer as that, or you can say this is the same as A times B square root of 3AC. So you can either leave your answer as that or write it as AB square root of 3AC. So here I have 27, A to the 9th, B to the 6th, C to the 3rd to the 1/6. Then because 27 it's a big number, I pretty much think I like here when I have 27, I know that it's 3 times 3 times 3. So I'm going to rewrite it as 3 to the 3rd power. Are you good with that part?
Yes.
Okay, then as we look at earlier up here, when we say the review, when you multiply more than one factors, here you need to raise everything to the power. When you have product of a power, you need to raise everything power. So that's what we're doing here. When I have 27, A to the 9th, B to the 6th, C to the 3rd, as we talked about earlier, I rewrite this as 3 to the 3rd. Then I need to raise each of these to the 1/6. So I'm raising this to 1/6. A to the 9th, I need to raise that to 1/6. B to the 6th, I also need to raise that to 1/6. And then C to the 3rd, I raise that to 1/6. Once I do that, when I have powered off another power, we know that we can multiply their exponents together. 3 times 3/6 is 1/2. 9 times 1/6 is 3/2. 6 times 1/6 is 1. And then 3 times 1/6 is 1/2. Does that make sense?
Kind of.
So pretty much we are, once I have that, I'm raising everything to 1/6 to a power. By raising this, I rewrite it as that. Notice here I put it in parentheses because this is A to the 9th. So A to the 9th raised to the 6th power. I need to raise each term here to the 6th power. So raise that to the 1/6, raise this to 1/6, raise the B to 1/6, and raise that to 1/6. And then once I get that, I multiply my exponents together, and then I get this. So rationalizing the denominator. So another issues that arise is that if you have a radical, like a square root, a radical signs in your denominator, we need to rationalize that, meaning we need to get rid of that so that it hits a whole number. So rationalizing the denominator involves changing the denominator from irrational to a rational number by converting it to the equivalent expression that does not contain a radical in the denominator. And then note, simplify expression with radicals generally includes rationalizing the denominator. So let's look at our first example here. To rationalize the denominator, multiply both your numerator and denominator by square root of 3. As you can see with this example here, I have 1 over square root of 3. My denominator is irrational. It's a square root of a 3. So to rationalize this, we're going to multiply both my numerator by a square root of 3 over square root of 3. Pretty much I multiply by the denominator, but once I multiply it, when I multiply my denominator by this, I also need to multiply my numerator by the same thing. And why do we do this? When we do this, we know that anything like 2 divided by 2 gives me 1, 3 divided by 3 gives me 1. In this case, square root of 3 divided by square root of 3 gives me 1. Our goal is to rationalize it, not to change it. So we multiply it by square root of 3 over square root of 3, which is 1. That's what it stands for. Then when I solve this, when I multiply this, we're going to multiply this across. 1 times square root of 3 gives me square root of 3. all over when I multiply 2 square root, I get that number itself. And this is why. When I multiply 3 times 3, I get a square root of 9. And we know that square root of 9 gives me 3. That's why a lot of times we skip this step right here and we jump onto this. So from square, when I multiply this 2, I get 3. And that is because when I multiply two numbers, my radicals goes away, or as you can see here, 3 times 3 is 9, so when I take a square root of 9, I get 3. So my answer is square root of 3 over 3. But this step, this middle step right here, is just to show you why do we get a 3. Let's look at our next example. When I have, this time I want to rationalize 2 over square root of x plus 1. So we need to multiply both my numerator and denominator by the square root of x plus 1. Square root of x plus 1. Set it equal to 2 times square root of x plus 1 is 2. Square root of x plus 1. All over, again, when I multiply 2 radical or 2 square root, they cancel out, so I'm left with x plus 1.
I got it now.
Okay, let's move on to the next example. Example 3. All right, again, here we have some alphabets and stuff, some variable. So to rationalize the denominator, multiply the numerator and denominator by a factor that change the denominator from an irrational number to a rational number. So we'll begin by writing the expression in exponent form. So I'm going to go ahead and write both of these in exponent form. So here, I'm going to reset this as equal to, I have a square root, so I'm going to put a parenthesis, 6a to the 5b to the third raised to 1/2. Because there's a 2 here, so a square root is the same as a power raised to 1/2. All over 12a to the 6b raised to 1/2. Are we okay so far?
Yes.
All right, then let's look at the next step. Now we need to rationalize this, right? Rationalizing this means I want my denominator to be the number itself. I don't want any of this. So the first thing for this one, what we're going to do, if I have an exponent of 1/2, I'm going to multiply to get a whole number 1, right? 1/2 plus what will give me a 1. That will be a 1/2 plus 1/2. So I'm going to multiply both of these. Since it's already 1/2, we're also going to do it a to the 6, b to the 1/2. So multiply both my numerator and denominator to a to the 6, b, and 1/2 of that. All right, are we okay so far? Still okay? All right, let's keep going then. All right, this is equal. Now when I multiply 1/2 and 1/2, meaning when I multiply 2 radical, I know that my exponent goes away, right? So here in my denominator, I'm going to be left with 12a to the 6b. So I'm going to write that, go ahead and write that, because I know that 1/2 times 1/2, when I have 2 of that, goes away. So I have 12a to the 6b. So that's in my denominator. Now in my numerator, they're both equal to 1/2, but my numbers are not the same. I have 6a to the 5th, b to the 3rd, 12a to the 6th, and b. So it can just goes away like my denominator. So we'll need to multiply each of these. So because they're both equal to 1/2, what I'm going to do it. I'm going to rewrite this as 6 times 12 times a to the 5th times a to the 6th times b to the 3rd times b to the 1/2. Pretty much I'm rewriting each terms in my parentheses together, so that I write my numbers together, a's together, b's together, everything raised to the 1/2. Are we okay so far? With that, if you have any question, please ask. Let me know now, so that I won't keep going any further with that. Okay, let me reduce that a little bit more. All right, if we are okay, then let's move on to the next step. All right, now my 6 and 12 are two different numbers, so I'm gonna go ahead and multiply those two numbers. 6 times 12 gives me 72. When I multiply two equal bases, my a to the 5th and 6th, we add their exponents. So 5 plus 6 is 11th, a to the 11th, and then b 3 plus 1 is 4, so b to the 4th raised to 1/2 all over 12a to the 6b. So my next step is to either multiply my numbers together. When I multiply two bases, I add their exponents. All right, questions with that? No? All right, as we look at earlier, when I have something raised to 1/2, then I need to take each term here and raise this to the 1/2. So I'm going to set it equal to 72 raised to 1/2. A to the 11 raised to 1/2 is 11/2. And then B, 4 times 1/2 is 1/2. 4/2, not 1/2, sorry. 4/2 all over 12a to the 6b. Okay, so that is my next step. Now that I have this, we're going to keep going. Now I have 72 raised to the 1/2. Can I simplify that any further? Now let's think of a factor of 72. Now, one number when I multiply, I could get a 72. I can do 1 times 2. Not 1 times 2. 1 times 72, 2 times 36, right? If I look at 2 times 36, I can see that 36 is a perfect square because this is raised to 1/2. 36 is a perfect square, so I'm going to break this down, okay? I'm going to say the 72 to 1/2. I'm going to rewrite this as 2 to the 1/2 times 36 to the 1/2, okay? So all I'm doing is taking this 72 and break it down to 2 times 36. 2 times 36 is 72, and then because the exponent is 1/2, they both get that same exponent. Then I'm going to look at my a next. Now a, I have 11 over 12. 11 is greater than 2. Sorry, 11 over 2. So I know that 11 over 2, I can rewrite this as 11 over 2. So if I have 11 over 2, I can 11 divided by 2, right? 10 divided by 2 will give me a 5, right? So that will give me a whole number. My goal is to see if I can ever get a whole number so that I won't have a lot of radical. So I know that 5 plus 1/2 or 10 over 2 plus 1/2 is 11 over half, right? So 10 over 2 gives me 5. Therefore, I can rewrite this as a to the 5th power times a to the 1/2. And then my last term is b to the b squared. And then everything, it's all over 12a to the 6b. Now you may wonder, why do I have to rewrite this? When I have 11 over 2, I have a fractions, and I'm trying to see if I can cancel or if I can get a whole number of that. So I know that 5 plus 1/2 is 11/2, or 10/2 plus 1/2, as we looked at earlier, is 11/2. So when I rewrite this, as you may see here, that I have a to the 5th in my numerator and a to the 6th in my denominator. And when we have whole numbers together, we can reduce this further, and that is why I rewrite it as that. So I'm going to go ahead and erase this up here. We don't need that. And then try to see if I can reduce this a little bit more. All right, now let's go ahead and finish this out. Now I have 36 to the 1/2. 36 to the 1/2, or square root of 36, is 6. So I'm going to write this as 6. 2 to the 1/2 is the same as a square root of 2. So I'm going to rewrite this as a square root of 2. A to the 1/2, it's the same as square root of a. So I'm going to write my a there. B to b square, it's a whole b. No, b square will still be a b square. So I'm going to keep that as it is now. So now so far I did this, and I did that. All right, let's continue with my a here. I have a to the 5th and a to the 6th. I have 5 a's on the top, 6 a's on the bottom, so I can reduce this as, cancel out my 5a on top. I'm going to cancel out 5 a's on the bottom, so I'm left with 1 a on the bottom. B here, I have b square and then b in my denominator, so I'm going to cancel out 1b in my denominator, 1b in my numerators, and I'm left with 1b. So I'm going to have 12a here with a b. That is in parentheses, so I'm going to write it in front right here because we have one more step to do. Now that I have that, I'm going to see, okay, can I reduce this any further? Yes, I can reduce my 6 times 1, and 6 times 2 is 12. So my answer for this is b square root of 2a all over 2a. I know that is a lot of steps. I'm not going to give you like a very complicated one like this for your homework or for your quiz or for your test. It will be much simpler, but this is to show you how to rationalize your denominator. Let's move on to example 4. To rationalize the denominator, multiply the numerator and denominator by a factor that changes the denominator from an irrational number with radical to rational number. So we look at an example like this. Earlier, you multiply by the denominator here. If you have a square root of x plus 1, then you multiply both your numerator and denominator by that. But this time, we have a square root of 2 minus, the minus is outside of the square root. Square root of 5. So square root of 2 minus square root of 5. To rationalize this, we need to multiply both my numerator and denominator by a square root of 2 plus a square root of 5. And this is called the conjugate of it. So square root of 2 minus square root of 5, the conjugate of that is square root of 2 plus square root of 5. What that means is that you change the signs in between. And then when we do that, what we're going to get is that 3 times square root of 2 plus square root of 5 is still going to be 3 times square root of 2 in parentheses plus square root of 5. I'm not going to multiply them in. All over, when I multiply these two together, I get square root of 2 times square root of 2 will give me a 2, and then minus 5. So anytime you multiply two radicals, you get that. And I'm writing it as this because if we are going to FOIL it out, the middle two terms cancel out. As you may already know by now that when you multiply two things, one with a positive and one with a negative, that is this you have the same two terms, then your middle two terms cancel out. And in this case, square root of 2 times square root of 2 is 2, square root of 5 times square root of 5 is 5, as we look at an example as example 1 earlier. All right, next we are going to say, okay, this is 3 times square root of 2 plus square root of 5 all over 2 times 5 is, 2 minus 5, sorry, 2 minus 5 is negative 3. Now, can I reduce this any further? I have 3 over negative 3. I can simplify that more. I can say I can simplify that to 1, right? 3 divided by 3 gives me 1. So my answer for this is, which is equal to negative square root of 2 plus square root of 5 all over 1, right? But we know that we usually don't write the over 1. So we can leave our answer as negative square root of 2 in parentheses plus square root of 5, or we can distribute the negative and say this is the same as negative square root of 2 minus square root of 5. Alright, example 5, last one. To rationalize the denominator, first again write expression in the exponent form, and then we're going to multiply the numerator by the factor that changed the denominator from irrational to rational. So here earlier example 3, I know it was a lot of steps and etc., right? So here, this one, we are going to do the same thing pretty much. So here, stay with me. I'm going to rewrite my denominator as an exponential form. So I have 2x to the 4th y squared to the 3rd power. Okay, so 1 over 2x to the 4th y squared to the 3rd power. Then we need to, earlier say that we need to multiply my denominator by we need to multiply my denominator. That will give me my irrational from irrational to rational numbers. So to multiply this, earlier we multiplied by the same thing, but this time we can multiply it to 1/2, and that is because of this. So I'm going to show you why is that. Sorry, this is supposed to be 1/3. I keep writing to the 3rd power. This is supposed to be 1/3. Alright, so here I'm going to say this is equal to, this time I'm going to go ahead and rewrite everything to the, raise it to the exponent. So this is 2 to the 1/3, x to the 4 times 1/3 is 4/3, and then y squared mean y to the 2/3, right? So this time we're going to go ahead and raise our exponents to all of the powers. Then I'm going to, this is what I'm going to multiply by. I am not going to multiply by the same thing. I'm going to see, okay, if I have 2 to the 1/3, to get a whole number of 1/3, 1/3 plus what will give me 1? 1/3 plus 2/3, right? So I need to multiply this by 2 to the 2/3. Alright, then I have x, I have 4/3. Alright, so 4/3, as we look at earlier, we need to get it to a whole number, right? Because I have 4/3, my number is already, 4 is already greater than 3. So that is pretty much 1 plus 1/3, right? Now, what do I need to get to a next whole number? I know that 6/3 will give me a 2, so I need 2 more. So I'm going to need to multiply x by 2/3 as well. But then lastly, I have y to 2/3. Alright, I have 2/3, so to give me a whole number, what do I need to multiply it by? 2/3 plus y give me 3/3. That will be 1/3. So I'm going to multiply this by y to the 1/3. So when I multiply my denominator by that, I need to multiply my numerator by the same thing. So 2 to the 2/3, x to the 2/3, and then y to the 1/3. Okay, now that we do that, in my numerator, 1 times this is easier because 1 times that number will be that number itself. So I'm going to go ahead and say 2 to the 2/3 will still be 2 to the 2/3. X to the 2/3 is still x to the 2/3, and then y to the 1/3 will still be y to the 1/3. All over. Remember when we say when I multiply this, I get that number itself. So 2 to the 1/3 plus 2/3 gives me 2. But then x is 4/3 and 2/3, so 6/3 give me x squared. And then y to the 2/3 plus 1/3 give me y. Then lastly, we're going to rewrite this as a radical form. So over here, which is equal to, I have my 3. They both have the same denominator for my exponent. So this is a cube root of 2 squared x squared and y all over 2x squared y. You can leave your answer as that. I'm fine with that. Or you can say, okay, I know here I have 2 squared, so I'm going to redo that as the cube root of 2 squared is 4x squared y all over 2x squared y. And that is my final answer. Right, let's look at the practice problem. I have 9 over square root of x plus 3. So I'm going to need to multiply both sides by square root of x plus 3 all over, I mean not both sides, both by numerator and denominator by square root of x plus 3. 9 times square root of x plus 3 is 9. Square root of x plus 3. When I have square root of x plus 3 times square root of x plus 3, I get x plus 3. And that is my answer for that. And then for letter B, we're going to go ahead and rewrite it in exponential form. So this is 1 over, in parentheses, 8x to the third to the fourth power. Okay, and then I'm going to rewrite both terms as 1 over a to the, not fourth, I keep writing 1/4. I apologize, guys. It's supposed to be 1/4. X to the third of 1/4. Then we need to raise each terms to 1/4. So a to the 1/4, and then x to the 3 times 1/4 is 3/4. Okay. Then to solve this, or to simplify this, we're going to need to multiply both sides by, alright, I have a to the 1/4. So what, to reduce that further, I'm going to rewrite this as, because 8, I know that I can simplify that more, because I know that 8 is 2 to the 1/3, right? So I'm going to come back here and rewrite all of this to 2 to the 1/3. So 2 to the third power, sorry, x to the third. So this is, will give me, sorry, 2 to the third power, so there will be 2 to the 3/4 also as well. Alright, now let's think of a number. If I already have 3/4, what do I need to get to a whole number? Then I only need to multiply to 1/4. Did you say something?
Yeah, I just said 1/4.
Okay, oh yes, thank you. And then x, same thing, right? If I have 3/4, then I will also multiply that by 1/4. When I multiply this, I multiply by the same thing. So 2 to the 1/4, x to the 1/4. Therefore, my answer for this is 2 times x to the 1/4, because they're both raised to 1/4, all over. When I multiply 2 to 3/4 times 2 1/4, it gives me 2. And then x 3/4 times x to the 1/4 gives me x. We can leave our answer as this, or we can rewrite it as a radical as the 4th root of 2x over 2x. Or B, letter B. So you can leave it like that, or in this case, it gives us answer choices, so we're going to choose B for that. In summary, to multiply, to rationalize your denominator, you multiply your both numerator by and denominator by the denominator of it, so multiply both of those by the same, except when you have an example like this one, as we looked at earlier, when you have a square root of 2 minus square root of 5, you multiply by the conjugate of it. And then here is your homework. For your homework, you only have to do number 1 through 4. So 1, 2, 4, and 5. So don't worry about 3 and 6. So just 1, 2, 4, and 5.